Good afternoon. So, our topic for today is all about Pythagorean theorem for plane trigonometry. Okay. Our objective for this lesson, we're going to discuss the part of the right triangle and the formula itself, the Pythagorean theorem, and of course, the proof of the Pythagorean theorem. Okay. So, we're going to define Pythagorean theorem on right triangles. And we're going to illustrate the proof of Pythagorean theorem. So the proof of Pythagorean theorem, let's say we have a right triangle here. So these triangles are, this triangle is divided into, so we have parts, we have C, B, and A, the parts of the right triangle. Okay, where C is your hypotenuse, the A and B are the legs of the right triangle. So this triangle is made up of three boxes or three squares rather. Okay, so each for each side has a square on it. Okay, so this A here is one side representing the one side of the square. So if you're going to get the area of this square, that's A squared, right? Same thing for B. Here, if you're going to get the area of this square, that's B squared. Same thing for the largest square here, which is C. So the area of this largest uh, square is C squared, based from the area formula for square. So in this case, the formula is C squared, which is equal to A squared plus B squared. So if we're going to translate this, so this will be the square of the hypotenuse. This one is the hypotenuse. Is the sum of the squares of the legs of the right triangle. Okay. So let's use that in our example. Let's say we have here. So we're asked to find for the value of x. Okay. So our value of x here is the hypotenuse. Okay, so the x is hypotenuse. So you're going to use the formula c squared, which is equal to a squared plus b squared. Okay, so you're going to replace c squared by x squared. Okay, so x squared, which is equal to 6 squared plus 8 squared. Okay, of course, we're going to evaluate 6 squared. So this will become x squared, which is equal to 36 plus 64. Okay, so evaluating the sum of 36 and 64, so this will be x squared, which is equal to 100. So to get the value of x, so since this is an x squared, you need to extract the square root of both sides of your equation. Okay. So this will become x is equal to 10. Okay. So the longest side of the hypotenuse is 10. Okay. Do we have any questions with our first example? Okay, nothing. Okay, so let's proceed. So x is equal to 10. Our second equation example is we're asked to find the value of y. So which means we're looking for the one of the legs of this triangle. Okay, so the y is you're given with hypotenuse 12 and one leg longer than the other, which is 8. Okay, so we're going to use c squared is equal to a squared plus b squared, the Pythagorean theorem. Okay, so we're going to replace c squared by 12 squared, which is equal to a squared. We'll replace it by y squared plus a 8. Okay, so we're going to evaluate 12 squared, that's 144, which is equal to y squared plus 64. Okay, so by subtraction property of equality, subtract 64 to both sides of your equation. That's 144 minus 64, which is equal to y squared plus 64 minus 64 in order for us to eliminate the constant on the right side of your equation, so that y squared will be the only term that will be left. So 144 minus 64 is 80. Okay, 64 minus 64 here is cancelled out because this is already 0. Okay, so this will become 80, which is equal to y squared. So in order for us to find for the value of y, we need to extract the square root of both sides of your equation. Okay, so this will become, so 80, so y, which is equal to, we're going to factor out 80 based on the given. So if you're going to factor out 80, one will be the perfect square and one will be the other, not the perfect square. However, if you're not sure of what you're going to do, if you're going to factor out 80, or if you're not sure of the square root of 80, you're going to factor it out, we're going to use the prime factorization method, which is 80. So here's our what we're going to do. So in order for us to determine what are the possible factors that we can use in order for us to solve for the value of y. Okay, so we have here 80. Okay, so we're going to get these factors. Let's say I'm going to divide 80 by 2. Okay, so to find the missing factor, you need to divide 80 by 2. So this is 14. Okay, so this is one way of determining the value of y, just in case you're not with your calculator. Okay, so we have to learn sometimes the traditional way of how we're going to determine the factors or the answers for our radicals without using calculators. Okay, by using this factoring method. Okay, so 40 is the missing factor, so 80 divided by 2, that's 40. Okay, so since 2 here is not factorable anymore because of the reason that number 2 is a prime number already. But here, we can still factor out 40. Okay, so let's factor out 40. So I'm going to divide 40 again by 2. Okay, so how do we find the missing factor? Of course, we're going to divide 40 by 2. And that's 20. Okay, so 20 is the missing factor. So 2 again is cannot be factored out anymore. So this is a prime number already. So 20, factor it out using the prime factorization. So this will be, if you're going to factor it out, okay. So 20, I'm going to divide 20 by 2 again. So 20 divided by 2 is what? Oh, that's 10. Okay. So again, 2 here is cannot be factored anymore. So we can still factor out 20 and 10, right? So 10 is the one that we're going to factor out. So I'm going to factor out 10. So let's say I'm going to divide 10 by 2. Okay. So how are we going to do this? So 10 divided by 2 is, so the missing factor is 5. Okay. The question is, are we do we need to factor out 5, or is 5 factorable? Because 2 For all we know that 2 is a prime number, so we cannot factor out anymore. So 5 is the remaining number. However, the question remains being asked, if we can we still factor out 5? No, because 5 is already a prime number. And what constitutes a prime number? The number 1 and the number itself. So that's a prime number. Okay. So what are the factors of 80? So that's the factors are 5 times 2 times 2 times 2 times 2. Or we can factor this, or so simplify this. So the factors are 5 and so 2 times 2 times 2 times 2, that's equal to 60. Okay. So back to the original answer. So I'm gonna rewrite because the equation has been erased. 6 squared, which is equal to a squared plus b squared. Okay, so this will be 12 squared, so y squared plus a squared. Okay. Okay, let's go back to our equation. Okay, let's go back. So c squared again is equal to a squared plus b squared. Okay, so what our equation a while ago. So this is 12 squared, which is equal to y squared plus 8 squared. Okay, so this is 144, which is equal to y squared plus 64, because 8 squared is 64. So by subtraction property of equality a while ago, that's 144 minus 64, which is equal to y squared plus 64, then minus 64. So we have here 80, which is equal to y squared. So we get the square root of both sides of your equation. Okay, so this will be, okay, the square root. So this will be y squared, or y is equal to the square root. Okay, so 16 multiplied by 5. So based from our factors here that we got based when we use our factorization 3. Okay, so this will be the square root of 16 multiplied by 5. Okay, so the other one is a perfect number, a perfect square number. The other one is not. So based from the rules of radicals, we're going to separate this. So y, which is equal to square root of 16 multiplied by the square root of 5. Okay. Based from the multiplication rule of radicals. Square root of 16 multiplied by square root of 5. Okay. So therefore, we can easily get the square root of 16. Therefore, y, which is equal to 4. So however, we cannot get the square root of 5 anymore. Remember, 5 is a prime number. So the answer is 4 square root of 5. Okay, so the value of y is 4 square root of 5. Okay. Do you have any questions? Okay, so this is our answer for problem number 2. Okay, let's proceed with our third example. Okay. Okay, so our third example is we have here two sides of the right triangle are given. So we can easily use the Pythagorean theorem for this matter using what formula? Okay, so this is c squared, which is equal to a squared plus b squared. Okay. So c squared, which is equal to a squared plus b squared. So the unknown hypotenuse is unknown, so we'll remain it as c squared. Okay. So this will be c squared, which is equal to 4 squared plus, okay, 8 squared. Okay. So we're going to evaluate the exponents here. So this will be c squared, which is equal to 4 squared is what? 16. Plus uh, 8 squared is 64. And c squared is 80. So almost the same value for okay. So to get the value of c, just extract the square root of both sides of your equation. Okay, just extract the square root of both sides of your equation. Okay, so this will be square root of c squared is equal to the square root of 80. Okay, we already have value for c, so we're gonna get the value of 80. Okay, that's 16. So if we're going to get the factors of 80, as our factors a while ago, okay, we got 16 multiplied by 5. Okay, so c, which is equal to square root of, okay, so this is square root of 16 multiplied by 5. And our answer for this problem is 4, the square root of 5. Okay, so do you have any questions with our second example? Okay, so let's proceed with our third example. So for square root of 5, remember this is our answer for example number 2. Okay, so let's proceed. Okay, so the same procedure for number 8 or example number 4. Okay, so the unknown is the hypotenuse. So same procedure, use the Pythagorean theorem. C squared is equal to a squared plus b squared. The undying formula uh, of Pythagorean theorem. Okay, so this will be what? Just substitute everything on the formula. So this will be c squared, which is equal to 6 squared plus 3. Okay, so c squared is what? So this is 6 squared is 36 plus 9. Okay, so c squared is equal to 45. Now to get the value of c, you need to extract the square root of both sides of your equation. Okay, so get the square root of both sides of your equation. Okay, so the value of your c now, it will depend on the equal part. So this will be square root of 45. We need to simplify square root of 45. We need to get the factors of 45. So to do this without using your calculator, you use the factoring tree method. Okay. So in this case, I'm gonna divide. I'm gonna find the factors of 45. So let's say I'm going to divide 45 by 5. Okay, what's the missing factor now? Okay, so 45 divided by 5 is 9. Okay, the question is, can we factor out 5 here? No. Why? Because 5 is a prime number already. Again, our definition of a prime number, so it states that get only the product of the number, number 1 and the number itself. Okay, so the factors of that number is the number 1 and the number itself. How about 9? Can we factor out 9? Okay, yes, we can factor out 9. Okay, so we can divide 9. So, of course, we cannot divide 9 by 5, so that's not the good, or that's not factorable. Okay, so I'm going to divide 9 by 3. Okay, how are we going to do to determine the missing factor? Just divide this one by this one. Okay, so what's the missing factor now? 9 divided by 3 is? Okay, that's 3. Okay, okay, so 3 is the missing factor. The question is, can we factor out 3? No. Why? Because 3 is a prime number. Exactly. So 3 is a prime number. And if you're going to get the factor of the prime number, is the number itself and the number 1. Okay, so the factors of this one, the factors of 45, we can say that it's 3 multiplied by 3 multiplied by 5. Or we can say that factors of 45 is equal to 9 multiplied by 5. Okay, that's also the same. Okay, let's go back to our equation here. Okay, so C, which is equal to square root of 45, so which is equal to what? Okay, extract the square root. So factors of 45 are 9 and 5. Okay, so this is 9, then multiplied by 5. Okay, so by using the multiplication rule for radicals, in separating these factors inside the radical sign, so this will be C, which is equal to, okay, so this is square root of 9. Okay, then multiplied by square root of 5. Okay, so the other one, we can get the perfect square, square root of the other number, because 9 is a perfect square number. So this will be C, which is equal to 3. Then we cannot factor out 5 anymore, because 5 already is a prime number. So it will remain as is. So this will become 3 square root of 5. Okay? So this is 3 square root of 5. So this is without using your calculator. Okay? Questions for our fourth example? Okay, so nothing. So we proceed with our fifth example. Okay. Okay, so you're given again hypotenuse. So what are you going to do? Use the formula for Pythagorean theorem. Okay, so C squared, which is equal to A squared plus B squared. Okay. Substitute everything on the formula. So this will become C squared, which is equal to 7 squared plus 10 squared. Okay. So this will be, so C squared, which is equal to So 7 squared is, we all know that's 49 plus the square of 10, that's 100. Okay. So this will be c squared. So 49 plus 100, that's 149. Okay. So to get the value of c, you need to extract the square root of both sides of your equation. Okay. So this will be c, which is equal to square root of 49. Okay, so we're going to get the factors of 149. Okay, let's try getting the factors of 149. Okay. Okay, so let's say I'm going to divide 149 by 3. Is it possible that we get is it possible that we can get a whole number? Let's try. Okay, so 149. Then we divide it by 3. This is a training ground, so we're not going to use a calculator here. Okay, so 149, then divided by, okay, 3. So this will be, okay, 4. So 14 divided by 3 is 12, so that's 4. 4 times 3, okay, that's 12. Okay. And we, what comes next after we get the product? We subtract. Okay, so we subtract here. Okay, so 149 minus, so this is 2. So 1 minus 1, that's 0. 4 minus 2 is 2. Then bring down 9. Okay, so 29 divided by 3 is what? Okay, that's 9. Okay. And therefore, 9 times 3 is 27. And 29 minus 27 is, okay, that's 2. Okay, so if we continue this process, that becomes 49.6666. Okay, so in other words, 49 is not factorable because 149 is already a prime number. Okay, so this one is a prime number, therefore we consider this as our answer for this particular problem. Okay. Okay, we can also try 149. We divide it by 9. Let's see if we get a whole number here. Okay, let's say 149 divided by 9. So 14 divided by 9. How many 9s are we needed to get a product of 14? Only 1. 1 times 9 is 9. Okay, and 49 and 14 minus 9 is what? 50. Then bring down 9. Or 5. Then bring down 9. Okay, so 59 divided by how many 9s are there in 59? We only need 6. Okay. So we only need 6. And 6 times 9 is 54. Okay, so 59 minus 54 is what? 5. Okay, so there are a lot of remainders. So we can also say that the answer is C is equal to square root of 49. Okay, do you have any questions with our fifth example? Okay, so nothing. Okay, so let's proceed. Okay, so same procedure with our 6th example. Okay, so you're given sides 3 and 7, you're asked to find the hypotenuse. So find the length of the hypotenuse using, of course, the undying formula, Pythagorean theorem. So that's c squared, which is equal to a squared plus b squared. Okay, so in this case, we're going to remain c squared. So c squared, which is equal to 3 squared plus 7 squared. Okay, so c squared is what? So 3 squared is 9 plus 7 squared is 49. Okay, so c squared, which is equal to 58. Okay, so in order for us to find for the value of c, you need to extract the square root of both sides of your equation. So we get the square root of this side and we get the square root of this side. Okay, so the radical sign here and the squared here will be cancelled out. Okay, so this will be c, which is equal to what? Square root of 58. Okay, so this will be square root of 58. Okay, so can we try factoring this out? So 58, let's say 58 here. I'm gonna factor out 58. Let's say I'm going to divide 58 to 2. Okay, what could be the possible value for another factor? We're going to divide 58 by 2, and that's 29. Okay, the big question is, can we factor out 29? Okay, so we cannot factor out 29 because 29 is a prime number and 2 is also a prime number. So therefore, the value of c that we all need is just the square root of 58. Okay, so this will be our answer for our particular problem. So do you have any questions with our topic for today? Or for 6th example rather. Okay, so let's proceed. What if your example goes like this? Find the length of all the sides you're given, the hypotenuse x plus 4. One leg is x plus 2, and the other one is just x. What if this is your example? Okay, these are going to do. Of course, you need to use the Pythagorean, right? So we're going to use the Pythagorean theorem, c squared, which is equal to a squared plus b squared. Of course, we replace c squared by x plus 4 raised to the second power, which is equal to x squared plus the other leg is x plus 2 squared. Okay. So in order for us to find the value of x, we need to expand this using our knowledge for special products. So we all know in algebra that a plus b squared, which is equal to a squared, plus 2ab plus b squared without using the FOIL method. Okay, using just this equation or just this or a minus. Okay. If we're going to expand this, so this will become x squared plus 8x plus 16, which is equal to, okay, so this will become x squared plus 4x plus, and then combine similar terms on the other side of your equation. Okay, so this will become x squared plus 8x plus 16, which is equal to 2x squared plus 4x plus 4. Okay. So your equation will our general equation for quadratic equation should be ax squared plus bx plus c, which is equal to 0. However, in this case, to make this equation look like this equation, we're gonna transpose all the terms to the other side of the equation. So this will become 0. Okay, we put 0 on the left side by commutative property of equality. So this will become 2x squared. Then by transposing x squared to the other side of your equation, so this will become minus x squared plus 4x minus 8x plus 4, then minus 16. Okay. Simplifying this quadratic equation, so this will be x squared, okay, minus 4x, okay, because 2x squared minus x squared is x squared. 4x minus 8x, that's negative 4x, and 4 minus 16, that's negative 12, which is equal to 0, okay, by commutative property of equality. The only factors that so we're gonna use three methods or three ways on how are we going to get the roots of this quadratic equation. What are those? Those are factoring, by completing the square, and by quadratic formula. Okay, in this case, we're only needing factoring, or I'm going to use the factoring method. Okay, so I'm going to factor this out. So this will be x minus 6 and x plus 2 is equal to 0. Okay, so these are the factors that we need. So if you're going to verify this, use FOIL method or long method. X times x, that's x squared. X plus 2x, or x times 2, that's positive 2x. Okay. So negative 6 times x, that's negative 6x. And negative 6 times positive 2, that's negative 12. So if you're going to combine, simplify this, your equation will just look like this. Okay. So this will be, so after we get the factors, we need to equate each factor into 0. Okay, so x minus 6, which is equal to 0. Therefore, by addition property, adding 6 to both sides of your equation, your x now will be, your x will be 6. On the other hand, okay, on the other hand, your other factor is x plus 2, which is equal to 0. So by subtraction property of equality, subtract 2 to both sides of your equation, then the value of your x will be negative 2. However, in this case, we don't have a measurement that has a negative number, so we're not going to use the value of x is equal to negative u as negative 2 rather as our value. Okay, so we're only be needing uh, the positive value of x, which is 6. We're gonna use this, okay? Because the other side, negative 2 plus 2, that will become 0. So that's, I think that's not possible. Okay, so x is equal to 6. Okay, so we're gonna find the length of each side of a triangle. Of course, the x is equal to 6 is the first leg, okay, of the right triangle. The other one is x plus 2, which is equal to 6 plus 2, or which is equal to 8. This is our second leg. Okay. And lastly, by the hypotenuse, which is equal to x plus 4, or which is equal to 6 plus 4, which is equal to 10. Okay. So these are the answers for our particular problem. Okay. So do you have any questions with our examples for today? Okay, so let's proceed with our check our understanding. Okay, or we're gonna use example number 8. So find the length of all the sides. Okay, the procedure here is different, similar with example number 7. The only difference is the hypotenuse is x minus 5 is one leg, and x minus 10 is the other leg. So same procedure with previous example. Okay, so we're gonna use Pythagorean theorem, of course, which is c squared, which is equal to a squared plus b squared. Okay, we're asked to find the length of each side. Okay, so this will become x squared, of course, which is equal to x minus 5 squared plus x minus 10 squared. Okay, so we're gonna simplify this equation by expanding those terms having a parenthesis. So this will become x squared, which is equal to x squared minus 10x plus 25 plus x squared minus 20x plus 100. Okay. For this one, this will become x squared, which is equal to, we combine x squared and x squared here, so this will become 2x squared, negative 10x, then negative 20x, that's negative 30x. And positive 25, then positive 100, that's positive 125. Okay. So in order for us to make our quadratic equation into the general form ax squared plus bx plus c, which is equal to 0. Okay. So you're going to subtract x squared to both sides of your equation. So this will be 2x squared minus x squared minus 30x plus 125. Okay, which is equal to 0. Okay, 2x squared minus x squared, of course, that's x squared already. Then minus 30x plus 125. Okay, which is equal to 0. Okay. So to find for the roots, we can either use the factoring, the completing the square and by quadratic formula. In this case, I'm gonna use factoring. So this will become x minus 25 and x minus 5, which is equal to 0. Okay. So after getting the roots by the factors using the factoring method, we equate each factor to 0. So this will become x minus 25, which is equal to 0. Okay, by addition property of equality, add 25 to both sides of your equation. So this will become x, which is equal to 25. Okay. On the other hand, this your equation here is x minus 5, which is equal to 0. So using addition property of equality, add 5 to both sides of your equation. The value of your x now, which is equal to 5. Okay, however, 5 is the hypotenuse. Okay, that's possible value, but we cannot have a negative number and a 0 as a measurement of the other legs of your triangle. Okay, so we cannot use the lower value of x, since although they are both positive integers, but we cannot use this. So what are we going to use is the larger integer, which is 25. Okay, so this 25 is your hypotenuse. Okay, the first leg, which is x minus 5, leg 1, which is equal to x minus 5, which is equal to our 25 minus 5, or that's equal to 20. Okay, the second leg is x minus 10, which is equal to 25 minus 10, which is equal to, okay, that will be the answers for our particular this one, so this one, and this one. Okay, so do you have any questions with our eighth example? Okay, so let's proceed. Okay, let's check your understanding here. Okay, so we're asked to find the length of the unknown sides in the following right angle triangles. Okay, so two of the I think three of the items are looking for the hypotenuse, where one item just only looking for the missing leg. Okay, so if you need more time, okay, just pause the video. Okay. Okay, let's answer the following problems. Okay, we have number one. Okay, the formula. We're just. I'm going to put the formula here. C squared, which is equal to a squared plus b squared. Okay. So for number one, so this is x squared, which is equal to 4 squared plus 5 squared. Okay. Of course, we're going to put the unit here. Okay, so x squared, which is equal to, so this is 16 plus 25. Okay, so the value of x squared, which is equal to 41. So getting the square root of both sides of your equation, so your x now will be equal to square root of 41. Okay. So the unit is in terms of centimeters. Okay. So 40 square root of 41. So 41 cannot be factored out because 41 is a prime number. Okay, so no more questions for our first example. Okay, let's proceed with second problem. First problem, second problem. So the same thing. Okay, so x squared, which is equal to, this is expressed in terms of decimal, 3.5 squared plus 6.4 squared. Okay, in terms of centimeter. Okay, x squared, that will be, so 3.5 squared, or in your standard calculator, so that's also the same as 3.5 times 3.5. Okay, so this will be 12.25 plus, so 6.4. And if you don't have a scientific calculator, you use your standard calculator, then 6.4 squared is also the same as 6.4 times 6.4. Okay, just remember, the exponent tells you to multiply the base in n times. Let's say if your exponent is 2, you will multiply the base in 2 times, or 2 times you will multiply the base. Okay, that's 40.96. Okay, so adding this, so x squared, which is equal to 12.25 plus 40. So x squared, which is equal to, okay, so 40.96 plus 12.25. Okay, that's 53 point. Okay, so that's 53.21. Okay, so get the square root. Okay, so if you're going to get the square root of this one, okay, so this will be a problem. Okay, so if you're using your calculator, the value of x will be 7.29, or approximate to 7. Okay, so 7.29. So this will be, if you're having difficulty with decimals, so just leave it as is. X is equal to square root of 53 over 31. That will be also the same. Okay, next, for number 3, uh, just a tip. So if you're in school, if in your school, if you're taught with how to get the square root manual, then you will be able to get x is equal to 7.29. Okay. Next, in number 3, uh, okay, so this is just the same, x squared, which is equal to 7 squared plus 10 squared. Okay, I think this is similar to our problem a while ago. Okay, so x squared, okay, this is 49 plus 100, or simply x squared, okay, which is equal to 149. Okay, so the value of x, just get the square root of both sides of your equation. Okay, so get the square root of this one, and then the value of your x now will be the square root of 149, because 149 is a prime number. Okay, so this is a square root of 149 in terms of unit centimeters. Okay, so we also forgot to write down the unit here. So this is in terms of centimeters. Okay, so how about this one? If you're going to use the formula, so substitute everything in the formula. So this will be 15 squared, which is equal to x squared plus 12 squared. Okay, so if you're going to evaluate 15 squared, this is 225, which is equal to x squared plus 144. Okay, so by using of subtraction property, so 225 minus 144, then x squared, which is equal to what? Okay, that's 81. Okay. So this is 81 as a perfect square number. So if you're going to get the square root of both sides of your equation, okay, so the value of x will be equal to 9 centimeters. Okay, so don't forget if you're there's a unit, don't forget to write the unit. If there's no unit, you can write units or just left just an integer. Okay, so this will be the answer for your fourth exercise, a fourth problem. Questions for our check under understanding. Okay, so let's proceed. If you're encountering one last problem, this problem requires almost the same with our that's 2x, 2x plus 5, and 2x plus 2. If you need more time, you need to pause the video. Okay, let's check your activity. Okay, so of course the same formula, the undying formula of Pythagorean theorem, squared plus b squared. Okay, so what you're going to do here, so this will be 2x plus 10 squared, which is equal to 2x squared plus 2x plus 5 squared. Okay, so if we're going to expand this, so this will be, we're going to use the special product. So this will be 2x squared plus 2 multiplied by 2x multiplied by 10 plus 10 squared, which is equal to 2x squared. So this will be 2x squared plus 2x squared, okay, multiplied by, and so this is plus 2 multiplied by 2x, then multiplied by 5 plus multiplied by 5 squared. Okay, so if we're going to evaluate this, so this will become, okay, so 4x squared plus, okay, 2 times 2x, 4x, so this 40x plus 100, which is equal to, so this is 4x squared, okay, so plus 4x squared, of course, 4x squared, okay, so plus 4x, 2x, this 4x squared plus 4x squared plus, okay, 20x plus 25. Okay, simplifying this, so this will become 4x squared. Okay, so plus 40x plus 100, which is equal to 8x squared plus 20x plus 25. Okay, so this will be, so to make this your equation in the general form of the quadratic equation, ax squared plus bx plus c, which is equal to 0, transpose everything on the other side of your equation. So this will become 0, which is equal to 8x squared minus 4x squared plus 20x minus 40x plus 25 minus 100. Okay, so this will become what? 0, which is equal to 4x squared. Okay. 20x minus 40x, that's negative 20x. Okay, minus 20x. Then 25 minus 100, that's minus 75. Okay, so we or also the same as 4x squared. This is also the same as 4x squared minus 20x minus 75. Okay, this is by trial and error method. Okay, so the factors of 4x squared, we can say that they are both 2x. Okay, we can also say that uh, the other one is 25. Okay, the other one is 3. Okay, which is equal to 0. Then we're gonna we'll try 2x minus 25 and 2x plus 3. Okay, so let's see if this is the factor that we're looking for. So we're gonna use the FOIL method here. Okay, so this will become 2x times 2x. Of course, that's 4x squared. Now, 2x times positive 3 is, of course, that's 6x. Negative 25 multiplied by 2. Okay, that's negative 50x. Okay, so negative 25, then, okay, that's already, but that's the not the factors that we're looking for. Okay, so if we're going to assess the middle term, okay, positive 6, negative 50, it's negative 44, that does not match uh, the given equation above. Okay, so this will be, we will try 2x minus 15 and 2x plus 5 is equal to 0. Okay, let's try this one. Okay, let's try 2x multiplied by positive 50. Oh, 2x times 2x, that's 4x, right? Okay, 2x times positive 5, positive 10x, negative 15 multiplied by positive 2 is negative 30. Okay, so negative 15 multiplied by positive 5. Okay, that's negative 75. Of course, this is equal to this one. Okay, so which means that we have our factors now, 2x minus 15 and 2x plus 5. Okay, so after we get the after we got the factors, we need to equate each factor into 0. Okay, so this will be 2x minus 15, which is equal to 0. Okay, to solve for the value of x, of course, 2x, which is equal to 15. Okay, and of course, we need the value of x. X is equal to divide by sides by 2, that's 15 over 2, that's 7.5. Or just simply 15 over 2. On the other hand, Okay, on the other hand, we get the other root. So 2x plus 5, which is equal to 0, of course, subtracting both sides of your equation. So 2x, which is equal to negative 5. And of course, divide both sides by 2 to get the value of x. X is equal to negative 5 over 2. However, we cannot use a negative value for our measurement because we don't have a negative value for measurement. So we will use the positive value part. Okay, which is 15 over 2. So if you're going to get the legs of the triangle, so this will be 2x or 2 times 15 over 2 or simply 15. So this is 15. Okay, this is 20 and this is 25. Okay, so the answers are here. So the value of x is 15 over 2. The answers are 15, 20, and 25. Okay? Do you have any questions with our topic for today? Okay, so if you don't have any questions, we'll see you on our next lesson. Thank you for listening.